Good day to you. I'm John Kolak with Grace Engineering, and today's webinar is going to be entitled Supervisory Safety Training. In previous webinars, I've gone through safety from different perspectives. We've talked about the engineering side of safety, namely arc flash risk assessments. We've talked about straight safety management, things like hazard analysis and control. Today's webinar is going to be talking more from the supervisory side of the house. Now, just for reference, for those of you that have never heard me before, my background in the electrical world is that I started off as a lineman. I served in a 4-year IBEW apprenticeship, and I climbed poles for a number of years before going back to school. I took Bachelor of Science degrees in electrical engineering and in management, and I also have a master's degree in occupational safety, and I'm also a certified safety professional. So let's go to the next slide and talk about what we're going to talk about today. In terms of the outline for today's presentation, we're going to cover some safety management basics, concepts that I think most managers would benefit from knowing. We're going to talk about performance planning and safety in a couple of perspectives. Number one is, how do we measure safety performance? And then how do we hold people accountable for their part of the process that contribute to this? And that's known as corporate alignment. And of course, any organization that's doing well has got the idea of alignment already figured out. From the top of the organization to the bottom, everyone understands how they fit into the process, the strategic goals of the organization, and that everyone is pulling in the same direction, so to speak. And really, the analogy of using a tug-of-war is apt in this situation. The team that wins the tug-of-war competition isn't the heaviest, and it's not even the strongest. It's the team that pulls in unison. So the idea of corporate alignment is central to basic management as well as safety management. Now, if we deviate for a moment and look at the graphic on the right, this illustrates an important concept within safety management and within management in general. Now, Edward Deming and others gave us the idea that a system is actually a series of integrated processes, and every process owner, whatever that might be, gets inputs from someone in the organization or perhaps an outside entity. They do something in the process part of it, and then they produce outputs that then become inputs for their downstream customers. Now, in the safety process, the inputs can come from varying sources. Everyone has some input into the safety process. For example, human resources, who they hire and how they promote people has a direct impact on safety. The inputs from the engineering side, like we talked about arc flash risk assessments, can have an input. The supervisory culture that they have in the organization also directly impacts safety. Those are inputs to the process. The outputs to the process include whatever it is that we're doing. From the engineering side, for example, one of our outputs would be an arc flash risk assessment study. But I also want to be very clear on something, and this is centrally important, that the reason we have systems in any organization is for standardization. We want to produce an efficiency. We want to produce things in a standardized way and as efficiently as we possibly can. We need to understand that an accident is a system failure. It is one of the outputs of the system. And just like other parts of our system exist to replicate things in an efficient manner, if we have a system defect, one of the outputs that will be replicated is an accident. And we've often heard of accidents happening in groups. Groups of 3 is often used as an example. The reason for the recurrence of the accidents is because the system didn't change. It's still going to produce that defective process or that defective output known as an accident. So we want to recognize that when we have accidents, it is a system failure. We're going to cover that a couple of times in today's presentation. Deviating back to the outline now, how we're going to measure safety is going to be from 3 perspectives. We're going to have some reactive measures. In other words, we wait for something bad to happen and then we react to that. In the olden days, we used to call that the fly, fix, fly procedure. This is how many companies manage safety. Fly, fix, fly goes back to aviation safety. If you can remember Chuck Yeager, who has the right stuff. The way it used to be done is test pilots would take an airplane up, they'd fly it out near the limits of its capability. Something bad would happen, and if they lived through it, they'd land the plane, talk to the engineers about it, they would make some kind of a fix to that, and then they'd repeat the process, fly it again. So fly, fix, fly is how most companies used to manage safety in a reactive manner. And of course, we understand that it's the most inefficient way you could manage safety would be to do the fly, fix, fly procedure. So that's really where hazard analysis was born. The idea of the benefits of anticipating and controlling hazards before they hurt someone is, of course, central to what we're going to do. So the reactive measures would fit in the output box on the little graphic on the right. Proactive measures, as I mentioned, is the process of anticipating and controlling hazards before they hurt someone and knowing that they've controlled contributors to accidents rather than just reacting to them. So proactive measures would fit in the input box of the process. And I'm also going to cover some comparative measures, things that you can use to compare your organization's safety performance to other organizations in a either of similar size or perhaps even within your industry. These are useful because I think managers need to have data. They like to have data to manage, but you want to properly measure the right things, and we want to make the right decisions and interpret the data correctly. So we want to make sure and talk about that in the presentation as well. The final concept we'll talk about is the difference between an accountability culture and a blame culture. And this is where performance planning can go south on you. The idea of accountability getting confused with being blamed for things that are not within your span of control. So we're going to talk about how to make sure that you have an accountability culture in your company, not a blame culture, and how that can work. And then, as always in these presentations, you can type your questions into the box, and I'll either answer them in real time or perhaps I'll wait till the end and answer your questions. So let's go to the next slide. This is a good time to begin with the end of the presentation, and that is that a key concept to understand is that good safety management is just good management applied to safety and health. Safety gets managed like any other part of the organization. Companies that are good, well-managed organizations, you can talk to the supervisors and they understand their role in the process. They understand what they're being measured on and how well they're doing on those measures. They have a good idea where they stand with their supervisor regarding their own performance planning. Of course, we have good measures. We manage to those measures, and we make adjustments to the system as needed in real time. That's exactly how safety management is done. So the key concept to understand is that if you're already a good manager, you're probably 85% of the way there to being a good manager of safety. And that can give us all hope that we don't have to learn a whole new skill set here. We really just need to understand how we fit into the process and manage to that. Let's go to the next slide. We need to revisit a couple of system safety concepts that will be directly useful in managerial safety that we're going to be talking about later on. And one of the key safety concepts to understand is known as life cycle management, also known as cradle to grave. The idea behind life cycle management is that the hazards associated with any system, whether it be the human machine or physical machinery, so to speak, have a life cycle to them, and the hazards change over time. And the safety system needs to adapt to those changes. So, for example, a piece of equipment, when you first install a brand new piece of equipment, the hazards associated with that are mostly what we call debugging the system, finding out any malfunctions or defective processes within the system, and we have to make changes on the front end. So we know there's more of those at the beginning of the life cycle. Over the bulk of the life cycle is the time where it's operational. The system is running and doing whatever it does. But then the system begins to change again near the end of its life expectancy, when the machinery is about ready to be retired. Again, maintenance cycles and everything can change, and they have to change to adapt to that. The human machine is just like that as well. A new hire in the system needs much more close supervision than they would over the course of when they become journey level people, so to speak, in the prime of their career, so to speak. But again, when they're a few months away from retirement, the human machine begins to break down. Physical injuries, the limitations of our physical self changes, and also our mental concepts, complacency and other things can slip in. So I think many managers would like to have a one-size-fits-all approach to safety, that you just have a standardized procedure and it always applies. That's not actually reasonable, because your safety system must adapt. So when you make system changes, like you hire a lot of people or you change to using external contractors or whatever you might be doing, your safety system needs to be fluid and adaptable to those changes. The idea that safety is a line management responsibility is also centrally important to understand. By line management, I'm referring to the managerial team that actually do the direct supervision and operation of the organization. These are the people who hire and fire people. They plan the jobs. They implement the production processes, and they also implement the safety processes. When I was a safety manager in the utility world, when I first hired into the company, I would occasionally get a phone call from a manager saying, "Hey, there was a violation out on the job. You need to send one of your people down here to close down the job, shut down that job." And of course, my first response is, "Why are you talking to me? It's up to you to shut down the job when the system is unsafe, not me." And the reason for that is that safety, and there's no escaping this, safety is a line management responsibility. It has to be managed directly. So when I was managing safety, I told my safety people, that if we do our job well, we'll kind of dissolve into the background. We're going to be feeding management expert advice. We're subject matter experts in everything from industrial hygiene to ergonomics to electrical safety. Our job is to feed management good information that they can then use to manage the safety process. And there's really no getting around this. The other thing to understand is that safety is a top-down methodology. It begins with the leadership of the company, and it's managed or driven down through the culture. Now, initially, when your safety culture is in the infancy stages, safety is literally driven. It is directed by management. As your process matures, you get more of a safety culture. Managerial roles switch from being more of a driver to a facilitator. In other words, the actual frontline workers are requesting what they need to manage safety in their scope of responsibility, and our job as management is to make sure we get them the resources and the support they need to manage the safety process. So just like anything else, the culture of your organization is also a life cycle. And when you're new to the culture, you're going to be driving the process, forcing them to do what you want them to do. Later on, it becomes much more facilitative, and of course, that's much easier and much more efficient to manage in a safety culture rather than a management-driven culture. The third idea we've already revisited, the idea that an accident is a system failure. In fact, some risk managers will amplify that and call it a catastrophic system failure. I mean, think about this. If you've had either an accident or a near miss that could have been a significant accident, many of the things we've done in the safety system aren't working. Now, don't misunderstand. I'm not saying the system is a catastrophic failure, but the system itself had a catastrophic failure. And what we mean by that is that, all of the hiring, the training, the engineering, the safety oversight, the managerial oversight, all the things we tried to do to manage safety didn't work, or at least they didn't interrelate well enough that we had a negative system output. Now, some of you may be thinking at this point, but wait a minute, John, there are something what we call acts of God, so to speak. If you want to know the actual data on that, it has been derived in system safety, and it is actually 4% of the time. 96% of the time when you have a negative system outcome, it is a system function. It is not personal. In other words, you could take one employee and pop another one in the same position, and they would have made the same mistakes. And that's because it is a system output, not a personal output, so to speak. So the key point to take from this discussion is that when we are managing safety, we have to find the root cause of system failures and make those changes to the system. If you don't change the root cause of it, the accident or the negative output will recur. It's the equivalent of taking a Chevrolet that's blue and painting it red and calling it a Lexus. If you're going to make it into a Lexus, you're going to have to change the fundamental components of that system. Changing the color and calling it something different doesn't change anything. In fact, it breeds a form of corporate insanity. So it's very important you understand that an accident is a system failure, and we must find and manage and correct the root cause of those failures in order for this to be an effective system. And then the final point I think is obvious at this point, and that is that a systematic approach works best. In other words, we don't want very much done ad hoc. The general rule in safety management is that the more variable a process is, the more dangerous it is. So we try to have standardized procedures, vetted procedures. We do training. We supervise people. We measure things. We correct unsafe behaviors. These are all things we do in a systematic way to manage the safety process. So your goal would be to have your people trained such that I could take one from this plant and move that electrician to that plant, and they wouldn't really miss a beat. The processes are standardized, the tools and equipment are standardized, and the training and supervision is also essentially standardized. So let's go to the next slide. We are now ready to talk about performance planning and how that can be used to influence and manage the safety process. Now, the adage you see down underneath here is apt. It's true. What gets measured and rewarded gets done, a very common managerial axiom that is used in industry. I'm reminded at this point of what in the high voltage realm, we talk about personal protective grounding that we use to protect workers from both shock and arc flash hazards on high voltage systems. And I've used this statement many times when I teach protective grounding, and that is that if you do protective grounding well and correctly, it is the gold standard to protect you from shock and arc flash hazards. You do it incorrectly and you'll precipitate an arc flash of unimaginable magnitude. Performance planning is like that in a sense, that being that if you do it well, it is the gold standard to get the organization aligned and to get efficiencies in the system and optimize your system output. You do performance planning incorrectly, you can demoralize the system can become disorganized, and inefficiencies and accidents can become much more likely to occur. So we're going to be talking about performance planning in terms of what do we measure, and how do we interpret the data the system generates correctly, such that we optimize the safety process, not hinder the safety process. Let's go to the next slide. Okay, let's talk about the objectives or the attributes of a good performance planning objective. The first point is important in the sense that we want to make sure that our objectives are just that. They're objective rather than subjective if possible. So ideally we'd like to measure hard data when we can. So we can measure things like having training events done, having arc flash risk assessments done, making crew visits. These are all things we can measure and observe. That's preferable to doing things which are subjective, which is something like saying you're going to optimize or reduce your accidents by 15%. Those kinds of things are subjective, very difficult to say how to do that. So to the degree we're able to try and generate hard data that we can measure and inject those into your performance planning objectives. The next thing, of course, is obvious, but it's strangely it's very uncommon to find people who do this well. That is that you must clearly outline what must be done to achieve each level of the rating. And let's tie the next point to that point. And that I would much suggest that you use graduated data rather than attribute data when you're measuring systems. Now, attribute data can be answered with the question yes or no. In other words, did you have an electrical safety class conducted, yes or no? So you can check the box, and that is attribute data. Graduated data measures quality. You can say, well, how effective was that electrical safety training? So to the degree you're able, I would recommend you have scales in your process ranging from, say, 1 to 5. 1 being totally unacceptable behavior, 5 being excellent, well, superior behavior. So my experience has been that if you give people the opportunity to be great, they often will rise to that occasion. It will be great. So when you have your performance objectives, I encourage you to use graduated data that can be scaled rather than just yes or no attribute data in your objectives. And then the next point is underlined because it's probably the most important part of the performance planning process, and that is to include only measures within the span of control of the employee. Now, this is centrally important because many organizations will include accident data, incident or accident data in the performance objectives of even frontline supervisors. And this is inappropriate because the frontline supervisor doesn't have control over all of the safety system. So what we will find is your executive management are the only ones that should normally have output related performance objectives. In other words, it is reasonable to hold the CEO and the executive management responsible for the incident rates and the accident rates in the organization. As you go further to the front line, the performance objectives must be much more activities-based rather than objective-based in output data, because they can't control, for example, a first-line foreman can't control who you hire, how you train them, the tools and equipment are provided. They only have control over what's going on in their specific crew. So we want to hold them accountable for what they can control, not for things that are outside of their control. If you deviate, if you violate this rule that you hold people accountable for things not in their control, it does two things. It's demoralizing and it undermines management's credibility with the employees. Now, I experienced this, and most people experienced it in their corporate career, where with respect to especially safety data, I would be doing the same thing year in and year out. I always gave it my best effort. I never withheld from the company. And even though we were a union shop, we gave it our all. Some years, the accident data would be good, and they would give us an attaboy for that, saying, good job, guys, you did great. The next year, after doing the exact same things, it seemed, I would get challenged or chastised, hey, we got to do better at safety. Well, of course, from our perspective, we weren't doing anything differently, and so as a result, it kind of bred a corporate insanity, if you will. We were kind of trying to figure out what management was thinking. One year they gave us an attaboy, the next year they'd slap us around, and we didn't do anything differently. So hold people accountable only for things within their span of control, and that is probably the central point in this discussion. And then the last point is that is subjective. Being fair and consistent in implementation to the degree you're able, that's good, especially with more frontline people, because they will share with each other what they're being held accountable for, and ideally would like to be consistent through the organization. So let's go to the next slide. Now Now let's talk about what we're going to measure in the safety process. And we're going to split them up in two different categories, reactive measures and proactive measures. Now at the top of the graphic you see here, we're going to talk about reactive data. Incidence rates are reactive data. We're actually quantifying or comparing the loss history for your organization against organizations of similar size. Severity rates are quantifying the magnitude of losses that occur. In other words, for example, how many lost days are associated with the accidents that you are having. Those are two reactive measures that are commonly used in performance planning. The third element you see is called experience modification rates. Now, EMR is actually related to workers' compensation insurance rates, but this can be useful because it quantifies the loss history you have within your same industry rather than just the size. So we'll talk about those three types of measures under the reactive umbrella. Under the proactive measures, we're going to be talking mostly about what we call activities-based measures, as we discussed in the previous slide. These are things that happen that can be measured in real time before we've had a loss. And the list I have here is by no means exhaustive. It's just examples. So for example, behavioral observations, that's proactive. We're observing unsafe behaviors and both at risk and safe behaviors on the job. And we're finding out that there are, of course, predictive value to the observations that we do. Now, behavioral observation programs are normally something that are done in more mature organizations. I wrote my master's thesis on behavioral safety, and I can tell you that many organizations implement behavioral safety programs when they don't actually have a mature process already, and that usually works out badly. So I recommend that behavioral systems be used in organizations that have a more mature safety culture. But once you have it, it will take you from good to great in the safety process. So behavioral observations are proactive measures. Things like completing training events, they're again proactive. We're trying to give people skills and techniques that they need to work safely on the job, hopefully not driven by an accident that led us to learn the training was a deficit in the system. Of course, maintenance is something else we do that's proactive. Most of us change the oil in our car at regular intervals, despite having no evidence that there's reason to do that. None of us have probably burned up an engine for not changing our oil out, but we religiously change it out anyway. It's a maintenance activity we do proactively. We don't wait till the engine's seized and then think about maybe we should have maintained that engine. And of course, there's many other activities-based measures as well. And of course, the last point is the important point, and that is really most performance objectives will have a combination of these. And I'll give you an example of that in the next slide. So let's do that. Let's go to the next slide. Let's look at an actual performance objective that was written for a senior manager in a utility company. And I hope you can read this slide, but this is not necessarily the best performance objective I've ever seen, but it does illustrate the range of both reactive and proactive data that we can measure. And it also has a scaling system that I think is relevant to discuss. Now, we won't go through every point in here. We'll just kind of hit the high points, but I think you'll quickly get the idea of what might be included in a performance objective for safety for a senior level manager. The first point is apparently in this organization, and I should point out at this point that this organization was in the developmental stages of their safety system. They did not have a completely mature system. So you'll notice that points 1 and 2 are both relating to losses in the system. If they've had a medical accident, they had a problem getting them to report promptly, so they had a 24-hour reporting window there. They also had a problem with follow-up on findings from accident investigations. Lessons learned weren't getting implemented. So items 1 and 2 were reactive in measure. Item number 3 is more proactive in the sense that they focused on training that particular year, and so they wanted to make sure that they had 100% of the required safety and health training that was mandated by OSHA completed. Again, this is an attribute data. It is not a graduated scale yet, but it is nonetheless proactive. We're not waiting for accidents to occur. We're training proactively. Item number 4 is absolutely reactive. They further sliced and diced their data by the divisional level, not just the corporate level. So each manager had what they call a divisional lost workday case rate. And so the number 2.5 is meaningless to you, but it means that they've had a hard data measure that they were going to measure for losses that happened, again, a reactive data. And then finally, item 5 is a stretch goal. They gave each manager the opportunity to target a specific part of the safety system they wanted to work on and develop their own measurement systems for that. So you can see items 1 through 5 are all things that are either reactive or proactive. that would be used to quantify the safety performance of this particular manager's division. Now, the scaling system you see down below, again, I'm not saying you would do the exact same scaling goal, but it is on a 1 to 5 scale. And of course, their raise, an item score of 3, would be basically compliant with OSHA's system. In other words, they couldn't be cited on that rate. They would complete the bare minimums. If they did that, they would probably get no raise or a small raise. On the other hand, if they got a 5, their raise would be commensurate with the level of their performance. So this is a good example of a performance objective that is for a senior manager level. If you were working more to the front line, you would not have these divisional lost workday case rates. You would have much more activities-based measures. So hopefully this is helpful to look at. So let's go on to the next slide. Expand a little bit the discussion on activities-based measures. And again, some of this is redundant. We already discussed the idea that training events are activities-based in the sense that hopefully they're done before an accident has occurred to drive the training event. But it is definitely measurable, both with attribute data, but hopefully better with graduated data to say, did we have these training events, and did we notice a change in behavior out on the shop floor? Were people wearing their gloves or their arc-rated clothing or following switching procedures, whatever was implemented under the training event? You should be able to observe those changes out on the shop floor. Especially for professional staff, achieving licensure can be an important activities-based measure that has a direct impact on safety. So for example, when I was managing safety in the utilities, I had industrial hygienists and nurse practitioners and safety professionals working for me. One of the things we set as a goal for my own division was actually to make sure that everybody achieved licensure. So the safety people got the certified safety professional designation, the hygienists got the CIH or certified industrial hygienist licensure, or professional engineers for the engineering group. These are all things that force people to expand and deepen their knowledge level, demonstrate proficiency. It has liability implications. So licensure is something for our professional staff that can be a good thing to do that is absolutely an activities-based measure. Of course, hazard analysis is the prototypical activities-based measure, assessing risk and quantifying that and managing the risk in real time rather than waiting for a loss. That's the perfect example of an activities-based activity. That sounds like an oxymoron, doesn't it? Of course, making crew visits. Some supervisors have trouble getting out on the shop floor, so some have committed to, for example, making daily crew visits and observing the work, reinforcing good behavior, correcting unsafe behavior. In fact, in OSHA, the OSHA Act actually calls something called regular supervision. In most jurisdictions, that's construed to mean that at least once a day, the supervisor is observing the work. This not only means that they're out there to correct unsafe acts, but to evaluate the effectiveness of the safety system. Engineering assessments like arc flash risk assessments, again, are an activities-based or proactive measure. And we can do that both to quantify risk and also lower risk by making changes to the system. For some organizations, they don't have a standing set of operating procedures, safety rules, or switching procedures. This can be a goal of a manager to say, well, for example, we're going to develop standardized switching procedures for all the main circuitry in our area. It's a requirement, but it's also directly connected to managing safety in a proactive way. And again, there are many others as well. This is obviously not exhaustive, but just to get your mind thinking about what might be included in activities-based measures. Let's go to the next slide. Let's talk about one of the comparative measures that can be used and is often used at the organization level, not the divisional or crew level by any means. It's known as an experience modification rate, or an EMR. Now, what's unique about EMRs is that they relate your loss history to the loss history of others within your same standard industrial code. So unlike some of the other incident rates we're going to cover, this relates to people doing the same kind of work you're doing. An average rating, just to calibrate your brain, would be 1.0. So if you had an EMR 1, that means that you're having the same amount of losses that are for the average of the industry in which you operate. Superior ratings would be less than 1, in particular a 0.3 rating, meaning you've had only 1/3 of the losses that others in your same industry are having. And a terrible rating would be 1.5 or worse. In other words, you're having 50% more losses than others in your organization. In your industry. So this gives us a way to kind of calibrate our brain, and we'll take a look at an example in the next slide. EMRs typically calculate your loss history based on a per $1 million of payroll, but it can vary by state. So some states have different comparative systems. But let's take a look at an example of this, which I think will illustrate how EMRs fit into and how it's absolutely a cost issue that can be managed. And the cost benefit of doing this is obvious when you look at this table. So let's go to the next slide. Let's take a look at EMR and the cost of workers' compensation insurance. And I should have mentioned in the previous slide that these calculations are usually on a 3-year rolling average. So EMRs, especially in performance planning, would be typically a long-range goal, and it would certainly be at the senior management level. But with that said, let's take a look at this EMR chart, and it will illustrate some of the cost issues associated with your safety performance or your loss history. Now, in this case, we're looking at the carpentry industry, which I think was SICO 5403. And what we have is the manual premium, and the insurance people have what I remember to be a very complex calculation to figure out what would be the manual premium for workers' compensation insurance for a given organization. So let's just say that in this industry, the manual premium was $500,000 or $500,000. You can see what they would pay for that insurance policy. If their loss history was 1.0, they would pay $500,000, 500,000 times 1. On the other hand, if they had exceptional safety performance, a 0.5 EMR, for that same policy, they'd only have to pay $250,000. It would be discounted because they're getting credit for their exceptional safety performance. And the reverse is also true. If they had 1.5 EMR, they would have to pay $750,000 for their workers' compensation premium on this particular organization because their loss history was worse. So there'd be a surcharge, if you will, for their poor safety performance. So I think it's obvious that there's a cost benefit to doing this. And of course, the larger the organization, the larger the numbers, but actually a smaller organization could actually, the impact of the improvement may be even more profound on the organization. So this is a good way to compare reactive data over a long term, over a 3-year rolling average. And as I said, this would be most likely useful for a senior manager's performance objective. Let's go to the next slide. Let's talk about some more reactive measures now. And the first one we're going to talk about is an incident rate, sometimes known as OIR. But either way, this is incident rates normalize industry histories per 100 full-time employees. So you'll see the number 200,000 in the calculations we're going to show you. 200,000 is essentially 100 employees at 2,000 hours per year. So this is a way of comparing organizations of different sizes. And they say that it allows accurate comparisons, but let's go to the third point as well. You have to use a little bit of interpolation when you're talking about this, because again, the loss history of a 50-person contractor against General Motors or something is, it is a comparison, but one must be thoughtful about how you interpret it. With that also said, the last point on this slide is important, and that a spike in incident rates can actually be a good thing. So for example, when you do training like on soft tissue injury prevention, we normally encourage people to report soft tissue injuries when you're starting to have symptoms, for example, of carpal tunnel syndrome. We would like for you to report that accident when it's still minor and it can be handled with work changes or perhaps some therapy, physical therapy, much cheaper than waiting until you can't feel your hands anymore and you have to have surgery and you're out for an extended period of time. So when we do soft tissue injury prevention training, we often see about a 15% spike in recorded incident rate, and that's a good thing. What we're going to do is compare how much the overall soft tissue injuries are costing us, and we will normally find that there's a significant improvement. We will pay much less severity rates when accidents are recorded early on. So don't overreact to a spike in your incident rates. It could be the result of something that we're trying to get the organization to do, which is early reporting. This also happens, interestingly enough, when you do violence prevention training. You'll get a spike in the reported number of violent acts on the job once they're defined. So again, management needs to be careful they don't overreact to data because they can actually shoot themselves in the foot, so to speak, by reacting to something that's actually a good thing. So let's go to the next slide. So let's look at an actual incident rate calculation for two organizations of decidedly different size. Organization or company A had 4 lost time accidents, but they had 40,700 man-hours of time worked. Comparing that against company B that had 56 lost time accidents, but they worked 1,211,000 hours. So which is the organization with the better loss history? Well, let's bring up the next point, and we'll see that Company A had a loss incident rate of 19.66, which means basically 20% of the company had a lost time injury on the job, which of course is horrific safety performance. Organization B, despite having many times more of the losses, but because they had so many hours worked, had about a 9% or around 10% of the employees in the company had a lost time injury on the job. Now again, neither one of these are exceptional safety performance, but it can certainly illustrate how normalizing the data can be very telling. Organization A had a far worse loss history than organization B. So that's just an example of an incident rate calculation. Let's move on to severity rates in the next slide. Now, severity rates are a good thing to include in any multi-perspective data analysis. And what we're trying to quantify with severity rates is the severity of injuries. In other words, how bad were the injuries, both in terms of human loss and also financial loss. Once again, it is normalized to 100 full-time workers. Now, you can also use other types of measures for severity, such as the raw medical expenses, the loaded medical expenses, total cost of accidents, total cost per claim. These are all severity measures that can be used to add multi-perspectives to analyzing the data and arriving at the right interpretation of the data. Now, severity rates may give insight into how badly employees are injured. Not all the time, but really the last point is what I wanted to discuss on this slide, and that is when severity rates go up, when incident rates go down, you need to look at the data. And again, when an organization measures just OIR and performance planning, there's an incentive not to report. And so when the severity rates go up, meaning the magnitude of injuries is increasing, when the incident rate is going down, the employers are trying to give you what you wanted. They're trying to give you lower incident rates, but what the severity rates are telling you is the only accidents that are getting reported are the ones that are so severe they can't be hidden. And again, this is very important. So be careful what you ask for in the management, because when you put a goal out there, you're going to get what they think you want. And so severity rates is a good measure to include in your evaluation. It may be telling. On the other hand, if your rates are going up and the severity rates are going down, again, that would be what we'd expect to see with an effective ergonomics program, especially field ergonomics. We'd expect to see the rates increasing a little bit, but the cost per claim going down. And that would be a good indicator that the system is actually working. So let's go to the next slide and we'll do a calculation. So let's revisit our company A and B, but this time we're going to be focusing on the number of total days lost by the accident against the same number of hours worked. So let's go ahead and bring up the data, and you'll see, of course, that I've pencil whipped the data to illustrate a point, and that is that they both have an identical severity rate. Company A had 9 work days lost with only 40,000 hours, calculates a severity rate of 44 lost days on the job on the average, and that would be a normalized rate. And company B, having 268 lost work days, normalizes to an identical rate. So both companies lost about 44 days of work for every 100 employees on the job. And of course, this would be a horrible rate in real life, but it does illustrate how comparing the data using these severity rate calculations can sometimes give us a bit better handle of comparing equal data across organizations of different sizes. So let's go to the next slide. Finally, let's talk about accountability cultures versus blame cultures. And this is centrally important, as we said, to performance planning, because effective safety management is when accountability cultures exist. Blame cultures actually are counterproductive to the organization. So let's just compare the two back and forth between accountability cultures and blame cultures, and I think the differences will become perhaps more apparent. For an accountability culture, for example, a person has a role in determining their own performance objectives. So they can not only say, well, this is the goal, what can I do to contribute to that goal? And I have a negotiation process with my supervisor as to what kinds of things I'm going to do to be measured against those goals. In a blame culture, the performance objectives are dictated by the supervisor. Often they're reactive-based cultures, for example, OIR or other severity rates might be in there, may or may not be in their control, but this is dictated to them, and you're just being told what to do. You're not actually given the opportunity to impact that. In a accountability culture, you're held accountable for only things within your span of control, and we've talked about that at length. In a blame culture, you may be held accountable for things that happen on your company level, again, things that are not in your span of control. And we've already discussed how that can be demoralizing and actually subvert management's credibility. In an accountability culture, your roles in the safety system are clearly defined. and they're hopefully as objective as we possibly can. In a blame culture, you really don't discuss your role in safety. You're only held accountable for outputs of the process. So the rule in many organizations isn't work safely, it's don't get hurt, and there's quite a difference between those two cultures. And finally, in an accountability culture, you receive periodic feedback, probably quarterly feedback from your supervisor regarding your performance with regard to your performance objectives. So by the time you get to your actual performance review, where you determine what kind of a raise you're going to get, there should be no surprise to someone in an accountability culture. You've had frequent check-ins with your supervisor, you know where you stand, you know how you're doing relative to your objectives. So that should be a low stress meeting because you understand what's happening. In a blame culture, you only hear about safety performance following an accident or in your end of the year performance review. That could be a high stress meeting because you're not sure what you're going to get, especially if your accident history hasn't been good. So these are just some examples of the difference between an accountability and a blame culture. And again, accountability cultures are robust, they're adaptive, they're fluid, and they promote excellent performance. Blame cultures are counterproductive. So let's go to the next slide and we'll bring this to closure. So let's go ahead and bring this to closure. Point number one is that we're going to manage safety like any other aspect of the business. Most organizations don't have productivity meetings, for example, but they do have safety meetings. And what we want to be stressing is the goal of your safety culture. When your culture is mature, safety and productivity become indistinguishable from each other. They are integrated. So you don't get paid for safety and work. You get paid for safe work on the job. So the idea of a safety culture might be the substance of a future webinar, but understand that as your culture matures, safety becomes integrated with the daily work and it is indistinguishable from the daily work. Point number two is you're going to develop valid and coherent safety measures. So measuring the right things within the span of control, which is the next point in the process. You get held accountable for your part in the safety process, which means your goals are adapted to your level in the organization. Again, the idea of using graduated measures rather than attribute data would be the appropriate thing to do to allow people to quantify the quality of their outputs, not just whether or not they had an output. And then finally, periodically, quarterly at least, monitor the effectiveness of the plan. Check in with your supervisor and make sure that the things you're held accountable for haven't changed, and to check in relative to what their assessment is of your skills with respect to the performance of your organization or your part of the organization. So with that, I'll take your questions. I'll go through them right now, and we'll come online and answer your questions. Feel free to type in your questions in the box. And you can also send your requests into Grace Engineering if you have an email. If you think of something after the fact, go ahead and send that in, and we'll get back to you on answers to your questions. Hopefully this presentation has been helpful to you. Good day.